Chapter 8 Introduction to Trigonometry Part 5. So up to Part 4 you have studied trigonometry ratios and the trigonometry ratios of some specific angles, the trigonometry ratios of complementary angles. Actually complementary angles are not there in the chapter, but still what you study, that is better clear. Now in this part we are going to see very important topic, that is trigonometry identities. Trigonometry identities. What is trigonometry identities? An equation involving trigonometry ratios of an angle is called a trigonometry identity. If it is true for all values of the angles involved. You see, for example, sin square theta plus cos square theta equal to 1. Okay, can put any values of that theta. Okay, can put values of theta, means it should be satisfied, then it is called identity. Clear? Now we will prove this. You take for our convenience, you take this is theta. Okay, so first what, in the left hand side you see sin theta is there. Sin theta means opposite side by hypotenuse side. So opposite side is what? AB by AC. Then cos theta. What is cos theta? Adjacent side. Adjacent side is BC by hypotenuse side. That is BC by hypotenuse side. Okay. Now you take left hand side. What is there in the left hand side? The left hand side you have sin square theta plus cos square theta. So now what I am going to do is this sin theta whole square plus cos theta the whole square. See, the sin square theta can be written as sin theta whole square. Cos square theta can be written as cos theta the whole square. Okay. Now you replace it. What is sin theta? AB by AC the whole square plus BC by AC the whole square. Understand? Cos theta and sin theta, you replace it. Now, squaring AB squared by AC squared plus BC squared by AC squared. Now, what you have to do? AC squared you take common. Means AB squared plus BC squared. AB squared plus BC squared. Okay, but we know that for Pythagoras theorems, that is AB squared plus BC squared nothing but AC squared. Okay, so this can be written as AC squared by AC squared. Okay, you write here by Pythagoras theorem, AB squared plus BC squared equal to AC squared. Understand? So now both numerator and denominator what same, so it will be 1. That is equal to right hand side. Therefore, LHS equal to RHS. Therefore, what is LHS? Sin square theta plus cos square theta is equal to 1. Right hand side 1. Correctly it is getting. Okay. Understand? So like this, what we can bring the identities. Understand? By using that sin theta and cos theta, you square it and add this, correctly we get 1. Okay, so that is called first identity, sin square theta plus cos square theta equal to 1. Okay, so like this you have totally 9 identities you have. Okay, one by one we will see. So the first identity is sin square theta plus cos square theta equal to 1. Right, first that one. What we proved that sin square theta plus cos square theta equal to 1. Okay. So from this identity you can write 2 more identities. Okay. The second one, This plus cos square theta bring this side means sin square theta equal to 1 minus cos square theta. 1 minus cos square theta. Same way, cos square theta equal to 1 minus sin square theta. Anyway, you can use. Okay. Cos square theta equal to 1 minus sin square theta. Okay, these three identity you are going to use in the problem. Okay, you have to remember always. See, if you remember this means you can write easily. Okay, two identities, two more identities easily we can write. Okay. Now the fourth one, secant square theta minus tan square theta equal to 1. Secant square theta plus tan square theta equal to 1. Understand? Same way, how you have written sin square theta plus cos theta equal to 1, same way you can write secant square theta minus tan square theta equal to 1. Understand? This also we can easily prove by using right angle triangle. How to find out secant theta angle, tan theta, then substitute left hand side, you will get easily right hand side. Okay. Now from this you write two identities. From this easily you can write two identities. First write secant square theta can be written as this minus bring this side means 1 plus tan square theta. Now this tan square theta can be written as this plus 1 bring this side. For my convenience, I am writing like this: tan square theta equal to secant square theta first, right? This plus 1 bringing this side means minus 1. So tan square theta equal to, easily you can write secant square theta minus 1. In the similar format, you have cosecant square theta minus cot square theta equal to 1. Cosecant square theta minus cot square theta, that's equal to 1. The same way, 8 1, same way, cosecant square theta, okay, keep this side, minus cot square theta bring this side, means cosecant square theta equal to 1 plus cot square theta. Okay. Then same way, cot square theta, you have to find out means cosecant square theta minus 1. Cosecant square theta minus 1. Okay. So these 9 identities, always you have to remember. Okay. So very simple. 3 identities remember: secant square, sin square theta plus cos square theta equal to 1, secant square theta minus tan square theta equal to 1, then cosecant square theta minus cot square theta equal to 1. Okay, these 3 you remember means easily you can write other things. Okay, these 3 very important identities, so always remember. So you can also easily remember by using a super hexagon method. Okay? These identities are easily you can remember by using super hexagon method. So only thing is you have to write here sin. First you have to write sin. Start with sin. Sin cos. Then tan. In order, right? Tan, cot, opposite cot. Sin cos, tan cot. Then sec cosec. Sec cosec. Okay. So easy to remember. This right side fully what is starting from C letter. That is cos, cot, cosec. That is sin ka cos, tan ka cot, sec ka cosec. So like this you have to remember. Understand? So this one complementary angles. That sin ka cos, sin 90 minus theta is cos theta. This tan 90 minus theta is cot theta. Secant 90 minus theta is cosec theta. Okay. So right side you have to remember always starting from letter C. Understand? Now you join the diagonal. This diagonal you join cross. This diagonal you join cross. Okay, this diagonal you join. Okay, all the diagonal you join. Okay, in center you put what? 1. Center you put 1. This is 1. Okay, center you put 1. Okay, Now you see sin square theta plus cos square theta is 1. Sin square theta plus cos square theta is 1. You have to go move like this. Okay. If you move like this means that is plus. If you move anti-clockwise means minus. 1 minus cos square theta is sin square theta. Okay. 1 minus cos square theta is sin square theta. So easy to remember. If you move, this is plus. Okay. If you move this side means minus. Put minus. Right. Sin square theta plus cos square theta is 1. 1 minus cos square theta is sin square theta. Understand? Now you leave this one. Okay, this triangle you leave it. Next one. Alternatively, you have to take. Okay, this one you leave it. Now this one you take 1. See, if you clockwise direction means plus. So 1 plus cot square theta is cosecant square theta. Getting or not? You see, 1 plus cot square theta is cosecant square theta. Okay. Then minus in this triangle only. Okay. First you take cosecant square theta minus cot square theta is 1. Cosecant square theta minus cot square theta is 1. Okay. Easy method. Now this triangle leave it here. Now here clockwise direction. Plus clockwise direction plus you. Tan square theta plus 1 is secant square theta. You see, tan square theta plus 1 here. Tan square theta plus 1 is secant square theta. Now anti-clockwise minus it, right? Secant square theta minus 1. Secant square theta minus 1 is tan square theta. Getting secant square theta minus 1 is tan square theta. Secant square theta minus 1 is tan square theta. Okay, this one leave it. So very simple. Using this easily 9 identities you can easily write. Okay. So again I will tell sin square theta clockwise that sin square theta plus cos square theta is 1. Anti-clockwise means 1 minus cos square theta is my sin square theta. Okay. Now same way here also 1 plus cot square theta is cosecant square theta. Cosecant square theta minus cot square theta is 1. Okay. Now here tan square theta plus 1 is secant square theta. Secant square theta minus 1 is tan square theta. So very fantastic idea. That is super extra. Easily you can remember the identities. Even what you can also remember reciprocal one. Sin ka reciprocal. Cosecant. You see opposite. Okay, sin ka reciprocal. Cosecant. Tan ka reciprocal. Cot. Okay, secant ka reciprocal. Cosecant. Okay, you can remember this also. Very important. This. Okay, sin theta reciprocal is 1 by cosec theta. Okay. Then cos theta reciprocal is 1 by sec theta. Okay. Then tan theta reciprocal is 1 by cot theta. So using this easily you can remember. Then one more thing you have to remember. Tan theta equal to sin theta by cos theta. This is also very useful. Next one, cot theta equal to cos theta by sin theta reciprocal. Because cot theta nothing but tan ka reciprocal, so just ulta right. That is sin cos theta by sin theta. Okay. So these identity, this idea, okay, this identity is very important. Clear? Always you have to remember. Trigonometry chapter means you have to remember. See now using this trigonometry identities, we will see the exercise problem. Exercise 8.4. First problem you see read. Express the trigonometry ratios of sin A, secant A and tan A in terms of cot A. You have to change into cot A. Clear? The sin A you have to write in terms of cot A. Okay, you have to remember, just remember sin A reciprocal. What is the reciprocal of sin A? Cosecant theta. Okay, cosecant. That means this sin A can be written as what? 1 by cosecant. Clear? So that what you have to do is, if sin means cosecant reciprocal. That's why we know that WKT means we know that cosecant square theta minus cot square theta equal to 1. That identity you have to remember. Okay, that is 7th identity. I have given a 9 identities. That 7th identity or super hexagon you remember. Cosecant square theta minus cot square theta equal to 1. Now you see this cosecant square theta you can change 1 by sin. This is nothing but 1 by sin theta whole square minus cot square theta. Keep as it is because we have to find out in terms of cot square theta, right? Now squaring 1 by sin square theta, that is squaring numerator and denominator. This minus cot square theta bring this side is 1 plus cot square theta. Okay. Now we need what? Sin square, sin theta. So both numerator, both side reciprocal you do. So reciprocal means sin square theta. This side by 1, the reciprocal means 1 by 1 plus cot square theta. Okay. Now easily we can write sin theta equal to take square root of 1 by 1 plus cot square theta. That is nothing but sin theta equal to 1 by square root of 1 is 1. So by this denominator write separately 1 plus cot square theta. The root. Okay. You see sin theta we have done theta. Change it fully A you write. Because in the secant square theta minus tan square theta equal to 1. This secant square theta is equal to 1 plus tan square theta. This minus bring this side. What is the reciprocal of tan? 1 by cot. Okay, cot that is. So secant square theta equal to 1 plus 1 by cot the whole square. Or 1 by cot square theta you can write 1 plus 1 by cot square theta. Right. This side you have secant square theta. Now take LCM. Cot square theta you take a cross multiply means cot square theta plus 1. Now we need secant theta only. So take square root of. Take square root means first to write 1 plus cot square theta. This can be written as 1 plus cot square theta. This is cot square theta. Okay. Therefore secant theta equal to. Now take a numerator and denominator square means root over 1 plus cot square theta by here take square root means cot theta. Okay, cot theta. Second one, secant A can be changed as fully A given means A you write. In general, what theta we used to write, but A given means A you write. Everywhere you write A, but this secant A in terms of cot. Okay, in terms of cot we have written according to the problem. Okay, express trigonometry ratios secant A in terms of cot A. We got it, right? Now tan A nothing but what? 1 by cot A. Tan A nothing but straight away you can write reciprocal of cot 1 by cot A. So tan A you are writing in terms of cot means 1 by cot A. Understand? So three things you got it. So like this easily you can do by using trigonometry identity. Now we will see the fourth question. Choose the correct answer. Okay, four options will be given. This problem, four options will be given. We have to find out the which option is correct. Okay, you see, this is the problem. This one problem is given. So here 9 is common. 9 secant squared a minus 9 tan squared a. Okay, you have to find out the value. The four option is 9. Okay, then other option 1, 0 will be given. Okay, you have to find out correct option. So here 9 you take common. 9 you take common means secant squared a minus tan squared a. We are getting the identity. Secant squared theta minus tan squared theta is 1. So secant squared a minus tan squared theta is 1. So 9 into 1, 9. So the option B is correct. 9. Same case, second one you have to do. Find the value of this. How to find out this means, you see, tan, secant, cot, cosecant given means for simplification purpose, everything you change into sine and cos. Okay. So here, this tan can be written as sine theta by cos theta. So you in identities you have to remember this one, very useful. Tan theta means, okay, sine theta by cos theta. Same way, secant is nothing but reciprocal of cos. So 1 by cos. Here also, cos by sine. Cos theta by sine theta. Okay, if you know this idea only, you can do this. Okay, so 1 by sine theta. That's why it is very important. That is equal to, now here you see cos theta is common. Sine by cos. So cos theta is common. You take common cos theta. Cos theta you take common means here nothing is there means cos theta you multiply. Plus sine theta. Plus 1 into, here also sine theta is common, you take LCM, that means sine theta plus cos theta minus 1. Now this is one factor, this is another factor, both you have to multiply. Okay, you see numerator into numerator I am multiplying. I am writing this for my convenience, sine theta plus cos theta. Bracket you group it, plus 1. Then this one sine theta plus cos theta minus 1. Okay, for my convenience I am writing both numerator into numerator multiply. Then sine theta plus cos theta, group it. Okay, now cos theta into sine theta is sine theta cos theta. Sine theta into cos theta you can write. Now in the numerator you see you are getting the form, which form? A plus b into a minus b, that is a square minus b square. So you, this fully what? Sine theta plus cos theta you take it as a. Okay, a. Then 1 is b. Okay, so that you will get the form a plus b, a minus b. You are getting the form a plus b, a minus b. Right? What is a plus b to a minus b? A squared minus b squared. So that you square it minus that one. Sine theta plus cos theta, the whole square minus 1 square. Okay, I am taking a, this fully a means a square means sine theta plus cos theta whole square minus 1 b square, that is 1 whole square by, keep as it is, sine theta cos theta, keep as it is. Now this sine theta plus cos theta is what? A plus b the whole squared formula. So that means a squared sine square theta plus b squared cos square theta plus 2 into ab sine theta into cos theta minus 1. Understand? For my convenience, I am writing a plus b whole square formula, a square plus b square plus 2ab. Like this also you can write. Okay, because here sine square theta plus cos square theta, you can apply the identity. That means it will be 1. It will be 1. Okay. Denominator write as it is. So this will be 1. 1 plus 2 sine theta into cos theta minus 1 by sine theta cos theta. So here plus 1 minus 1 get cancelled here. So you will get 2 sine theta cos theta. by sin theta cos theta. Now you see in the numerator you have sin theta is the same and cos theta same, numerator and denominator. Okay, the factor is okay, common factors are same. That's why you have to cancel it. Therefore, the answer is 2. C is correct. Understand? So like this, easily you can do the choose the correct answer. Okay, sometimes you see should 1 mark. You have to do what this much big, so that you have to what minimize the steps. You have to do very fast. Clear? You have to minimize the step because here a plus b equals to a sin square theta plus cos theta. Here 1 straight away you write. Okay, then this is 2 sin theta cos theta. So 1 minus 1 cut means we will get 2 sin theta cos theta means both cut means 2. So in MCQ type you have to do very fast. Clear? Shortcut way you have to do. Right? Now we will see the very important problem, 5th problem, that is prove the following identities. This is this problem very important. Proving the identities, given identities is very important. Clear? Many types you have, many problems you have. You have to practice on practicing only what you can do easily. Understand? So that first what you take left hand side. You take left hand side means you have to bring right hand side. When you take left hand side, simplify means you can bring right hand side. That is the idea. Or you take right hand side, then simplify means bring left hand side. Anyway you can do. Clear? Anyway you can do. So for our convenience, what here cosecant theta minus cot theta whole square you have to bring. So that better you take this right hand side and simplify means left hand side easily will get. Right? Even left hand side you take also you can do. Here normally we used to do take this form, that is conjugate form. We will take conjugate form and easily you can do. That's why you take right hand side and bring left hand side. Proof. I am taking right hand side. That is as it is you write first. To cancel conjugate method. Here plus there means you change. Middle sign you have to change. Okay, this is very important method. Okay, you have to learn. Don't know means try to learn. So multiply numerator and denominator. You have to divide. Clear? 1 minus cos theta multiply means you should divide. So that you will get a plus b to a minus b form. That is the idea. Clear? Now numerator is the same factor you have means 2 times you have means 1 minus cos theta the whole square. X into x square like that. Okay. Now here a plus b to a minus b is 1 squared minus cos theta the whole square. That is equal to 1 minus cos theta the whole square. Keep as it is. Don't again expand. Clear? No need. You simplify this 1 minus cos square theta. What is 1 minus cos square theta? Sin square theta. 1 minus cos square theta is what? Sin square theta. Right? Here you write. We know that sin square theta plus cos square theta equal to 1. Okay, this formula remember means easily you can write 1 minus, that is you bring this side means sin square theta will get. Okay. Now both squaring you have, so you can write common 1 minus cos theta by sin theta whole square you can. Understand? Whole square you can do. 1 minus cos theta by sin theta whole square. So what you can do is divide separately. Okay, divide separately. That means 1 by sin theta minus cos theta by sin theta the whole square. Now you see 1 by sin theta is what? Cosecant theta. 1 by sin theta is cosecant theta. Cosec theta minus cos by sin is what? Cot theta. You see the proof correctly you will get cot theta. Sometimes you have to see the proof and write. So 1 by you will get idea. Okay. See the result. Cos theta minus cot theta we have to prove. So 1 by sin means cosec theta. Correctly we will write. Okay. Then cos by sin is cot theta. Okay. Just you can recall. Okay. So that is left hand side. Therefore, LHS equal to RHS. Hence prove. Prove the following identities. Fifth problem. Second one. Cos A by 1 plus sin A plus 1 plus sin A by cos A equal to 2 secant A. You see here you have to take only left hand side. So if you take left hand side, simplify only, you will get 2 secant A easily. Understand? So you see the problem, accordingly you have to take. So now I am taking this left hand side as it is. Cos A by 1 plus sin A plus 1 plus sin A by cos C. Now what you have to do is take LCM, both numerator multiply. Just to multiply both numerator or denominator, both denominator multiply means just cross multiply. Cos into cos, cos square A plus this one 1 plus sin A the whole square. Correctly you have to write 1 plus sin A the whole square. Now just a simplification only, okay. Cos square A plus this is A plus B whole square formula you put means 1 square, that is 1 plus 2 into 1 into sin A 2AB, right? 1 is there, that's why no need to write, plus sin squared A whole divided by 1 plus sin A into cos A. Keep as it is, don't multiply, okay. Sometimes numerator will get same factor, that's why easily we can cancel it. Understand? So now what you have to do is cos squared A plus sin squared A, group it, that means 1, that is 1. Cos squared A, or you write sin squared A plus cos squared A. Group it, plus 1 plus 2 sin A whole divided by denominator right as it is. Now apply that identity, sin squared A plus cos squared A is 1. This is 1, 1 plus 1, 2, straight away right. This is 1, okay. So 1 plus 1, 2. That 2 is what? You should not add, that is separate, unlike term, that is, okay. 2 is with sin A. How to write as it is? You cannot add 2 plus 2, 4, okay, it cannot. Because this 2 is alone, this 2 is with sin A, you cannot add, clear? What you can do is 2 you take common. 2 you take common means 1 plus sin A. You see, you are getting the same factor. Getting or not? Yes. So numerator, denominator, same factor means what? You will divide, cancel it. Now this is 2. 2 into 1 by cos A is secant A. You have to remember 1 by cos A is secant A, reciprocal. Understand? Just you bring that super hexagon, okay. Super hexagon bring this, you can easily write cos just opposite secant, right? The diagonal way cos opposite secant, okay. That is right hand side, that is right hand side. So LHS equal to RHS. So next we will see fourth problem. 1 plus secant A by secant A equal to sin square A by 1 minus cos A. How to do? You take left hand side and simplify. You may get right hand side. Okay. LHS you take. Now what I am going to do is the secant A use reciprocal. Clear? 1 by 1 plus cos A by 1 by cos A. Understand? That is equal to the numerator take LCM. Cos A you take LCM means what you will get? Cos A plus 1. Okay. or here into, you can do into also better. This whole divided by, so into you do means 1 by cos A by 1. So both side cos A cancel. So this can be written as 1 plus cos A. By 1 is same thing. By 1 is same thing. Right? Now take right hand side. Because you left hand side simplified to 1 plus cos A. Sometime okay, you take separately right hand side and you do what you are getting. Same thing if you get means no problem. Left hand side equal to left side. Okay. Sin squared A, how will you write? 1 minus cos squared A. Formula. Identity, right? Now this 1 minus cos squared A can be written as A squared minus B squared form. That is, this is 1 squared minus this is cos A the whole squared. We are writing in the form of A squared minus B squared. You have to apply formula that 1 A plus B into A minus B. That means 1 plus cos A into 1 minus cos A. By denominator write as it is so that you are getting the common factor. You see, numerator, denominator, common factor. So that will be cancelled, means 1 plus cos A you are getting or not. That is right hand side. Okay. Right hand side and left hand side getting same answer. Therefore, LHS is equal to RHS. Hence proved. Hence proved. Understand? Sometime we have to do separately. Clear? Separately you do. You can easily get left hand side and the right hand side. Same answer you will get. Same answer you will get. So that hence proved. Or you can do one thing also. Here itself what? Into conjugate you can take 1 minus cos A by 1 minus cos A. Clear? Then you apply means same thing only. You say right hand side straight away you will get. Like that also you can do. For a change, okay, I have done this method. Left hand side, right hand side separately. This method also possible. Clear? So like this same type of problem I will give it as homework. Do homework problem for better practice.